All right, this is the last lesson for the first week of school being closed. So this is going to finish up the law of cosines and just a quick little review of law of sines. So we are going to have to start being able to determine when you do which law. And so just to reiterate, if you are given two angles and one side, that's going to be law of sines. Two angles and the opposite side is also going to be law of sines. And to determine that that is the opposite side, is the letter of the angle will match one of the sides. Or we'll say label. Label will match one of the sides. Okay, and then for law of cosines, we're going to use law of cosines when we have three sides, or when we have two sides and their included angle. And the included angle label will not match either side. Okay, so in our first example, we're just going to determine whether law of sines or law of cosines can be used to solve the triangle. All right, so on the first one, it looks like we're given two sides and an angle. So that could be either one. So we have to look and see if that angle label matches either of the sides, and it does not. So that's going to be law of cosines. All right, then for the second one, we have two angles and a side. So two angles and a side automatically is law of sines. Oh, okay. It looks like something weird happened whenever I downloaded this, but this is supposed to be lowercase and this one is supposed to be lowercase. So some kind of autocorrect happened on mine. Hopefully it didn't happen on yours. So on C, we're given two sides and an angle. So two sides and an angle could be either one. And then if you notice that the label on the angle matches the label on the side, on one of the sides, then it is going to be law of sines. All right, and then for D, we're given three side lengths, and three sides is law of cosines. Okay, so you have to determine that, right? The next couple of examples are going to be applications of law of cosines. So for example 2, a port is 50 miles due north of a lighthouse. A ship is 30 miles at a bearing of north 37 degrees east from, not from, the lighthouse. How far is the ship from the port? Okay, so we have the port is due north from the lighthouse. So I'll just drew a vertical line, and we know that distance in between is 50 miles. All right, a ship is 30 miles at a bearing of north 37 degrees east from the lighthouse. So we're going to make that rotation from the lighthouse. So like this. So from the north, we're going to rotate 37 degrees towards the east. So I'm going to say that looks about right. And that's going to be where our ship is. And then the question is, how far is the ship from the port? So this is what we're looking for. So I'm going to call that distance x. there's one more thing we know. Oh, this is 30 miles. So we know two sides of the triangle and the angle between. So that's 100% law of cosines. So what we would say is that x squared is equal to 50 squared plus 30 squared minus 2 times 50 times 30. This is just the law of cosines times the cosine of 37 degrees. All right. Now it's possible the answer might be left like that on the ACT. On our test, I don't think it would be. I think they would probably have you go ahead and do 50 squared plus 30 squared. And go ahead and multiply 2 times 50 times 30. But then after that, we're just looking for the square root. And that's it. And this would be in miles. All right. Example 3 is for all you softball fans. A batter hits a ball to center field. The center fielder then throws the ball to third base, and then the third baseman throws the ball home. The distance from the center fielder to home plate is 250 feet. The ball took a 45-degree angle from the third baseline. The distance between the bases is 60 feet. Draw the triangular path the ball took on the diagram below. And then we're going to figure out how far the center fielder threw the ball. All right, so we're going to go from home plate to center field. So just like straight to the middle. And it does tell you that's 240 feet. Okay, so that's the first. The center fielder gets the ball and then throws the ball to the third baseman. Which the distance, we don't know. All right, and the third baseman throws the ball home, which is a distance we know because in softball, the bases are 60 feet apart. All right, and then one more thing we know is this angle is 45 degrees. Okay, so we have two sides of a triangle and the angle in between. So that's definitely law of cosines problem. So you guys go ahead and set it up on your own, please. That should be squared, not degrees, sorry. Okay. So then we can do some squaring and adding here. All right, and then some multiplying. Okay, and then finally, all of that just goes under a square root. And that's going to be in terms of feet. So in case you're wondering, that is 202.08 feet that the center fielder threw the ball. Okay, the last thing we're going to talk about from these two sections is Heron's formula, and it's another formula to find the area of a triangle. So given any triangle with side lengths ABC, the area is going to be given by area equals the big long square root of S times the quantity S minus A times the quantity S minus B times the quantity S minus C. All right, and then you also need to know what S is. To find S, you're going to add A, B, and C together and divide by 2. So no matter what, S is going to be larger than A, B, and C. So we don't have to worry about getting a negative underneath that square root at all. Okay, so for example 4, we're going to find the area of a triangle having sides 11 feet, 16 feet, and 24 feet. So the first thing we have to do is find S. So we'll just add 11, 16, and 24 together, and then divide that by 2. All right, so S ends up being 25.5. All right, so then to find our area, it's going to be a big long square root. We take 25.5 and we multiply it by 25.5 minus 11, and multiply it by 25.5 minus 16, and 25.5 minus 24. And I'm just going to have you guys leave it like that. I know that you can type that in and get all that, but just leave it like that. And the answer in this case is going to be in square feet. Okay, so on your assignments, I'm going to have you on page 416. On 31 through 36, I just want you to determine law of sines or law of cosines. You don't have to solve them, even though the directions say to. All right, and then on the rest of them, it's actually the next page. Do what it says to do.